what is the climate topic is that subject is becoming more and more important. It is clear. The change in the science that has become clear in the past few years is that the climate system is more sensitive than we realized. And we are closer to dangerous levels of atmospheric greenhouse gases in the atmosphere than we realized. That realization has come about primarily from two different sources. One of them is improved information on the history of the Earth, how the Earth responded in the past to changes in its boundary conditions, including the composition of the atmosphere. And the second is observations of what is happening now in response to the changes that humans have made in the planet's atmosphere. That information has actually led us to conclude that the target level that we should be aiming for atmospheric carbon dioxide, which is the primary, the most important change that humans are making to the planet, is a change in atmospheric carbon dioxide, because that gas, much of it stays in the atmosphere for more than 1,000 years. So it is, and it is causing the largest change in the planet's energy balance. So to start with the effects that we see occurring on the Earth today, well, the one that I'm sure you've heard about is the loss of sea ice in the Arctic. That is an example of a tipping point where the forcing reaches a point such that changes begin to happen, and then those changes themselves drive further changes, because as the sea ice melts, it exposes a darker ocean, which absorbs more sunlight, and that causes more melting of additional ice. And so suddenly, in just a 2-year time period, the amount of Arctic sea ice has been reduced to only a bit more than half of what it was 30 years ago when we started to make satellite measurements. That's a reversible tipping point, because if we would restore the planet's energy balance so that there was as much energy coming in as going out, then that sea ice would stabilize. But there are other potential tipping points which are much more threatening and which we dare not cross. One of them is the stability of the ice sheets, because if either the West Antarctic ice sheet or the Greenland ice sheet became unstable to the point that it began to disintegrate, or a large fraction of it began to disintegrate into the ocean, it could cause sea level rise of several meters. And we know from the U.S. history that there have been cases when ice sheets have disintegrated rapidly, and we've had sea level rise as fast as 5 meters in 1 century. So we don't want to cross that tipping point. The other one, which is irreversible on any time scale that humans can think about, is the extermination of species. And again, the history of the Earth tells us that when there have been global warmings of several degrees, it has led to the extinction of more than half the species on the planet. And of course, other species came into being over hundreds of thousands of years, but on any time scale that we can imagine, it would be a much more desolate planet that we would leave to our children and grandchildren if we left. And the thing about ecosystems is that we're now putting pressure on species because a given temperature line is moving poleward at a rate of about 60 kilometers per decade on the average. And species can attempt to move to stay within their climatic zone, but some of them don't move as easy as others. And as long as that movement, the total movement, was moderate, then it doesn't cause a big problem. But now for 30 years, that rate of movement has been occurring. And if we follow business as usual with more and more emissions of that in turn affects other species which are interdependent and can cause ecosystems to collapse. So we don't want to do that. So there are a number of different criteria that show that we've already got into the dangerous zone. We've increased CO2 from 280 to 385 parts per million. And we can already see not only the effects on the temperature lines and sea ice, but mountain glaciers are receding all around the world. And they're receding at a rate which, if we stay on business as usual, within 50 years, almost all of them will be gone, which will have a huge impact on freshwater supplies for hundreds of millions of people. Where rivers that originate in the Himalayas, and Rocky Mountains, and Andes, and other mountains provide fresh water throughout the summer and fall. And once those glaciers are gone, you'll still have the fresh water runoff in the spring, but in the summer and fall, the rivers will tend to run dry, and there will be major problems. And just to mention one or two more, the coral reefs are under stress due to both the acidification of the ocean, which that's a direct effect of carbon dioxide, which makes the ocean, the CO2 makes the oceans more acid, so they tend to dissolve carbonates, such as the shells and skeletons of many of the life forms. And also the increasing temperature is also a stress on coral reefs. So all these things tell us that what we probably should have realized earlier but didn't, and that is that if we want the climate to stay close to what it has been through the Holocene, the current interglacial period, the last 10,000 years, then we're going to have to keep CO2 to no more than about 350 parts per million, and maybe less than that. And that's still possible. But there's some, in order to achieve that, if you look at where the CO2 comes from, the fossil fuels, oil, gas, and coal, you'll see that from the size of those reservoirs, that coal becomes by far the most important issue. We've already used about half of the oil, and it's very difficult to stop the emissions of oil to the atmosphere. And it doesn't matter that much how fast you put it in the atmosphere, because it's going to stay there 1,000 years anyway. So, and you can't capture the CO2 coming out of the tailpipe. But if we burn all the fossil fuels, we will be heading the planet back toward the ice-free state with sea level 75 meters higher. So we simply can't do that. And that's only become crystal clear, I'd say, in the last few years. So the only practical solution is to say we're either going to leave coal in the ground, or we will use it only at power plants where we capture it and put it back under the ground. And that, if we don't do that, we're sentencing our children and grandchildren and the unborn to a future which is going to be pretty difficult for them to control, because once things begin to cascade, then the problems with the ice sheets and with the extermination of species will really be out of their control. And so we just can't continue to ignore that fact, and it's not sufficient to set goals. You can't say, oh, I'm going to reduce emissions by 20% by 2020 or 80% by 2050. Those goals, you can prove, will not be met if you do not have a moratorium on new coal-fired power plants and a plan to phase out the existing ones over the next 20 years. It's a very simple problem. Just look at the magnitude of the carbon in the oil, gas, and coal reservoirs, and recognize that the oil is, the big pools are out of your control. Russia and Saudi Arabia are not going to leave their oil in the ground. That tells you you've got to control the coal. And is something that should not be